And welcome everybody to another edition of Smokin Conversations with Sakina-Ra. Yay! And thank you all for coming. And I really want to give a really special thanks to my sister Gemini, the goddess. She wasn't supposed to be here tonight, but really I appreciate her for coming, y'all. And I really want to thank everybody for being in the chat tonight. So thank you so much, RTG nephew. Thank you so much, Shala Ben Ya. I appreciate y'all and everybody else who's in the chat, in the StreamYard, YouTube, wherever you are. I appreciate y'all so much tonight. I want to pick up tonight where we left off. I believe it was in December. And I want to run through where we were. Again, we're going to start with the climate change and what is going on with the climate change. So I want to kind of see what's going on. Sister, do you want to talk for a minute and see what's been going on with you this week? I know it's hump day.
It is.
Yeah, it's hump day. So, everybody kind of want to see what's going on in the hump day in the middle of the week, because that's mainly the busiest day of the week, right? People think it's not, it's Monday, but really it's Wednesday. That's why they call it the hump day, because you really get a lot in that day. And then when Friday comes, it's another one of those days. And then after Friday, you really relax. So Tuesday is kind of wishy-washy, and then Thursday is kind of wishy-washy, but it's always Monday, it's always Wednesday, and it's always Friday. But Wednesday and Friday is like the worst days. Even sometimes Monday. Those be the worst days of the week to work. So again, how was your day today?
It was long. It was okay. It's long. It's been a long week on my end. There's a lot of changes that you have to keep up with every day. Some more 10,000 changes today. Same shit, different day.
Yeah. Well, we appreciate you. Being one of those employees that's been going through since last month. We really appreciate your dedicated service and what you're going through right now. So let me say that.
Appreciate it.
Let me say that.
Peace to the chat. Peace, Solid Y'all Ben Ya, and peace, Brown Table Gang. Our favorite two people.
Yes, and they're always here, loyal. I love it. So moving forward, let me bring up this presentation right quick so we can get into it. I don't want to waste a lot of your time because I appreciate you being here with me. So let me know when you see my screen.
Yep, I can see it.
All right. Is it sharing?
Mm-hmm.
All right.
Can you send that copyright to me? I don't have that. I've been trying to find where y'all got this copyright from, but I haven't been successful. So,
well, it's in our drive. I told you before. It's in our drive.
Oh, okay.
So, just going real quick. Just going to real quick. This was our climate solution is peace. Let me go back. This climate solutions are peace solutions. So this is where we were a little over a month ago when we were talking about the climate change. I'm sorry, and we were talking about the geopolitical military tensions, and we were talking about the wars were not the primary driver of global warming. We were saying it wasn't the primary cause of global warming, but we were trying to point out, why is it not going backwards? We were trying to draw a connection to a systematic vibration at this point because of the greenhouse emissions that it caused from industries and agriculture and transportation, and it contributes to agricultural degradational exacerbations in the climate crisis. But we don't have to worry about that now because we're not going through wars. However, at that point, the climate changes ratios that they had, they didn't have an accurate equation on these numbers with volcanic eruptions, flooding, catastrophic weather, earthquakes, and whatnot. But now we need to rethink these numbers because of the bombings and the other energy of human activities and wars that trigger these volcanic eruptions and the other hypotheses. And so we also knew that the season changes had effects on the volcanic eruptions with the landslides, floodings, and other mechanisms with those, and they have effect on dam breaches and other phenomena that intertwine with weather disruptions. So that also played an effect on greenhouse from the volcano disruptions. So they were wondering about the effects of Greenland melting with those disruptions. And finally, you had impact on the wars with this, they called it a systematic thing, which is more like vibrations, but still you had carbon emissions and whatnot for these prolonged wars with the ones in Iraq and Afghanistan. And so, again, the CO2 emissions was carbon emissions in the air, and then those were other pollutions that we were looking at that were causing these holes in the ozone layer and whatnot. And so, long and behold, we still have a problem with global warming and what these emissions do and what they may not do to the ecosystem, right? And so even though they don't have a direct connection saying what it is and what it's not, but they are saying that these emissions and carbon and the CO2s are part of these drivers. So they say some of them are human, and then they're saying some of them are not. So for the entire year of 2024, they said Yellowstone recorded 259 earthquakes with the magnitudes of 3.3, and that comprised 2 earthquakes above the magnitude of 22, I'm sorry. And then in California, being a seismatical active, they were due in the location along the Pacific Ring of Fire. That's something that Ibiza likes to talk about. And they experience their own frequency seismic. Those events are possible that the tremors are felt in California during the period that was due to the same seismic activity rather than just originating from Yellowstone. So they had when they totaled up all these earthquakes from 2004 till now, they came up with a total of 396,602 total earthquakes around the world.
Hey there, science buffs. Hey there, science buffs. Welcome to Smokin Conversations with Sakina-Ra's presentation to climate changes. Today, let's dive into the jaw-dropping stats of earthquakes in 2024. Hold on to your hats because we're talking about a whopping 396,602 recorded earthquakes worldwide. Now let's break it down. Of these, 11 were absolute giants, measuring above magnitude 7. These are the ones that really shake things up, causing massive damage and making headlines. Next, we had 104 earthquakes between magnitude 6 and 7. Still pretty intense, right? These are strong enough to rattle buildings and cause significant disruptions. Moving down the scale, there were 1,548 earthquakes between magnitude 5 and 6. These can definitely be felt and can lead to damage, but they don't pack the same punch as the bigger ones. Then we had a staggering 13,718 quakes measuring between magnitude 4 and 5. These are often felt, but rarely cause major damage. And get this, there were 42,361 earthquakes between magnitude 3 and 4. and a mind-blowing 94,770 between magnitude 2 and 3. These are usually too small to be felt by people, but are still detected by seismographs. Finally, brace yourselves, because we had an incredible 244,090 quakes below magnitude 2. These microquakes are mostly imperceptible, but they remind us that the Earth is constantly moving. Let's not forget the significant events like the Noto earthquake in Japan on January 1st, which had a magnitude of 7.5, causing widespread damage and tragic losses. And in Turkey, the Sulusare Tokat earthquake on April 18th, with a magnitude of 5.6, causing injuries and property damage. So, there you have it, folks. 2024 was a year of intense seismic activity, reminding us of the powerful forces at work beneath our feet. Stay curious and keep exploring. Until next time, stay safe and stay informed. And stay tuned for more with Smokin Conversations with Sakina-Ra, sponsored by Silverback Nations. We appreciate you.
So now, in climate change is part 2, with the tornadoes, hurricanes, and cyclones. The big debate now is about the cloud seeding that has been going around decades, and it's still not fully understood on the large scale, which has impacted weather and climate. And scientists generally agree that cloud seeding can enhance local precipitation. But whether it has a long-term widespread effect on climate is still uncertain. So the key points are the short-term localized impact. The cloud seeding primarily affects regional weather conditions rather than the broader climate system. Now, it enhances rainfall or snowfall in targeted areas, but it doesn't fundamentally alter large-scale weather patterns. It limited influences on climate change and climate systems, and is driven by greenhouse gases and deforestation and the industrial activity. And while cloud seeding works by modifying existing cloud moisture, it's not creating new water vapor, and it doesn't generate more water. It just redistribute it. So the concerns about unintended consequences, some argue that prolonged cloud seeding might distribute natural precipitation cycles or shift rainfall patterns, potentially affecting ecosystems and agricultural in unpredictable ways. And so scientific uncertainty, while cloud seeding has been studied for over 70 years, the long-term effect on atmospheric dynamics aren't fully understood. So most climate models don't account for cloud seeding as a significant driver of climate change. And the ethical political debates, some worry that large-scale weather and modifications could lead to conflicts over water resources or unintended side effects. If one region gets more rainfall, it could mean less for another. And this is one of the arguments I heard with them dumping water in California, and then they might need it later on, especially after that fire and everything that just happened. So while cloud seeding does not influence local weather, most experts don't see it as a major player in the global climate change, at least not compared to fossil fuel emission, which is something that they're also having a problem and arguing about, and industrial pollution and deforestation. However, as cloud seeding expands, especially in drought-prone areas, the conversation is a broader effect and it's far from over. So, drought-prone areas is where cloud seeding is actively used or considered, including several areas in the United States and around the world that frequently experience low rainfall, water shortages, and high evaporating areas due to cloud conditions or climate conditions. So the drought-prone areas seeding in U.S. and Western areas, that will be California, where frequently battle drought, especially in agricultural regions like Central Valley. It also includes Nevada. It's arid climate with strong needs for water conservation. It would include Utah, snowpack independent state, cloud seeding used to increase water supply. It would include Colorado because it relies on snowpack and faces reoccurring drought conditions. It would include New Mexico because of the desert that it climbs with severe water shortages. It also includes Texas because it's partially in the west where long dry spells are common. And in the Great Plains and Midwest where I live, it would be in North Dakota because it used cloud seeding to seed and reduce hail damages and enhance precipitation. And in Kansas and Oklahoma, it faces frequent drought conditions through cloud seeding, and it uses it more limited. So the globe drought and prone areas using cloud seeding is United Arab Emirates, the UAE. It invests heavily in cloud seeding to combat desert dryness. China large-scale cloud seeding, especially around Beijing and drought-stricken regions. India uses cloud seeding. Australia uses cloud seeding. Saudi Arabia uses cloud seeding. Cloud seeding is a drought solution. While cloud seeding can enhance precipitation, it does not create water. It simply maximizes moisture in the atmosphere. Excuse me, y'all. And as a severe drought condition where there's little to no cloud cover, cloud seeding is less effective. This is why many drought-prone areas still rely primarily on water conservation, desalination, and improved irrigation rather than cloud seeding alone.
From the dawn of civilization, humans have gazed upon the heavens with a mix of awe and longing. Welcome to another edition of Smokin Conversation with Sakina-Ra. We see how we've celebrated the life-giving rains and trembled at the devastation of drought. Our ancestors appealed to deities for favorable weather. Today, we seek to take control of the skies ourselves through the controversial practice of cloud seeding. Imagine a world where we could summon rain to parched farmlands, quell raging wildfires, or even weaken the fury of hurricanes. This is the tantalizing possibility offered by cloud seeding. Cloud seeding is a weather modification technology aimed at increasing precipitation from clouds. It involves introducing small particles, often silver iodide, into the atmosphere. These particles act as condensation nuclei, providing a surface for water vapor to condense and form raindrops. While still an evolving technology, cloud seeding has been deployed in various parts of the world, with proponents touting its potential to alleviate drought, boost agricultural productivity, and mitigate the impacts of climate change. At the heart of many cloud seeding operations lies a rather unassuming chemical compound, silver iodide. Silver iodide might not ring a bell for most, but this yellowish salt plays a pivotal role in manipulating the delicate dance of water molecules in the atmosphere. So why silver iodide? The answer lies in its unique crystalline structure. Silver iodide crystals bear a striking resemblance to ice crystals. This similarity is crucial because it allows silver iodide to effectively mimic ice in the clouds, providing a template for water vapor to latch onto and freeze. When dispersed into clouds that are already laden with supercooled water droplets, water existing in liquid form below freezing, silver iodide particles act as seeds for ice crystal formation. This process, known as heterogeneous nucleation, is essential for raindrop formation in many cloud types. As more and more water vapor condenses and freezes around the silver iodide particles, the ice crystals grow larger and heavier. Eventually, they become too heavy to stay aloft and fall as precipitation. In essence, silver iodide acts as a catalyst, accelerating the natural rain-making process. The allure of cloud seeding, particularly in regions grappling with water scarcity or prone to drought, is undeniable. The potential benefits extend beyond simply increasing rainfall totals. Proponents argue that cloud seeding can help replenish dwindling reservoirs, boost agricultural yields by providing much-needed water to crops, and even suppress hailstorms that could damage valuable crops. Furthermore, cloud seeding has been explored as a means to mitigate the impacts of climate change. As global temperatures rise, leading to more frequent and severe droughts in some regions, cloud seeding is seen by some as a potential tool to adapt to these changing climatic conditions. The ability to induce rainfall could prove invaluable in maintaining agricultural productivity safeguarding water resources, and even influencing the intensity of wildfires. The promise of cloud seeding, however, is not without its skeptics. While the potential benefits of cloud seeding are enticing, it is crucial to acknowledge and address the potential environmental and health impacts associated with the long-term use of silver iodide. One primary concern is the accumulation of silver in the environment. While silver is not acutely toxic, its long-term effects on ecosystems are not fully understood. Silver can accumulate in soils and water bodies, potentially impacting aquatic life and altering the delicate balance of natural ecosystems. Research on the potential toxicity of silver iodide to humans is ongoing, and the scientific community is still working to fully understand the long-term consequences of its use in cloud seeding. Some studies have shown that silver iodide can be toxic to certain aquatic organisms, raising concerns about its potential impact on the food chain. Furthermore, the effectiveness of cloud seeding itself remains a subject of huge and complex debate. While some studies have said to shown promising results, others have yielded inconclusive or even contradictory findings. The complex interplay of atmospheric conditions, cloud types, and other factors makes it challenging to isolate the precise effects of cloud seeding and determine its overall efficacy. Thank you for joining. Be sure to stay tuned for topics like this and more on Smokin Conversations with Sakina-Ra, sponsored by Silverback Nations. We appreciate you.
So most of these programs have been in operation for decades, with few tracing the origins back over 70 years to earlier research from at least 1940 to 50. Like North Dakota, it's one of the longest running programs since 1950. California follows up with their drought program from the 50s to the 60s, with Colorado running right behind them from the 70s. Then you have Nevada, they were running in the 60s. You have Utah starting a cloud seeding program in the 50s. Wyoming opened one up in 2000. Texas opened up a cloud seeding in the 1990s. Ohio opened up one early in the early 2000s. And then Mexico had an intermediate engaging into its cloud seeding, with more consistent programs emerging over the last couple of decades. However, in 2024, the United States experienced a significant number of floods and disasters, according to the National Center for Environmental. And there were 27 confirmed weather, climate disasters and events and losses. And there was $100 billion. Each of those were major floods. And so you can find all this information. I'm gonna drop all this stuff in a link. And these floods, some of the floods were due to unprecedented things. So it's hard to, I separated them, but when it comes to these disasters, floods, typhoons, hurricanes, and rainstorms, it's hard for them to separate them. So when it comes to these unprecedented floodings across the regions, including Central Asia, Africa, West Africa, Southeast Africa, and Europe, we have different kind of systems. But right now, what's going on, I'm going to leave these websites up with the information, because all of this is regarding 2004. So, we had the tropical storm Alberto, and that was in June of 2004, that hit from Mexico. And it ran all the way through Montreal and Alberto, and it destroyed, it was widespread. That hit thousands of people as well. And this was on AP News. I'm going to drop these links in there as well. But the impacts of floods are multifaceted, and the devastation impacts on the people. It impacts the economics and the environment. And it addresses challenges and requirements of combinations of proactive measures, such as the improvement on the policies, the planning and the resilience of the infrastructures, and they need early warning systems and disaster preparedness for that. Sometimes with these hurricanes and floods, even when they try to get the people out, we've seen this even in California, fighting those fires. Some people, they move as fast as they can. Some people don't have nowhere to go. Some people, it's devastation at its best. So this is CAF for the Emergency for America. And this is one of the floods that happened last year in 2004. And so you see how this is with the water when it gets this high. And so I'm going to get into another part of this, because when we talk about I'll be damned, most of these areas where these floods happen, these infrastructures, we talking about dams. And some of these dams have been up longer than 70 years. They've been up since the Civil War. And we talking about inspections on these dams.
Now, in the US, several southeastern states are seeing significant flooding after Hurricane Helene hit the region. At least 63 people have died, and officials fear that number will increase. More than 3 million people are without power. The Category 4 hurricane is the most powerful storm on record to hit Florida's Big Bend area and moved north into Georgia and the Carolinas after making landfall overnight on Thursday. With gusts of 140 miles an hour and heavy rain, damages from the storm are expected to reach upwards of $100 billion. Well, the storm unleashed one of the worst flooding in a century in North Carolina, essentially cutting off access to the western part of the state with forced road closures. In Atlanta, 13 inches of rain fell over 48 hours, the most the city has seen over 2 days in over 140 years. Florida's Governor Ron DeSantis says the authorities there are assessing the storm's damage.
Clearly, you saw a storm surge in excess of 15 feet. So that is much, much more significant than what we've seen in recent storms like Idalia that hit, and certainly Debbie. And that is really, really destructive. So as you look around here, you see some homes that are now just rubble. This stuff's coming in, it's fierce, and it just is unstoppable. So there's a lot of damage that we're seeing here.
Well, Christian Benavides is Miami correspondent with our US news partner CBS. He told us how other states have been affected by Hurricane Helene.
The Carolinas seen the most deaths up to this point. There are also parts of North Carolina that currently have no cell service or internet service. So there are officials that are trying to get communications up and running there. This was a monster of a storm. If you just take a look at it, it was fast moving. It's still over Tennessee. The state of Tennessee, in fact, has some flash flood warnings at this point. The cleanup will take some time. It's quite incredible to see some of the images, particularly when you look at Florida and Cedar Key. This is a small community which was just impacted by Idalia last year, and now you have this major storm impacting it once again. These are homes that have been completely wiped out. There is just so much rebuilding that needs to take place across the Southeast. At this point, we've got about 3 million customers, 3 million homes that have no power across the Southeast. Most appear to be in Georgia, where there are about 1 million customers without power there. But again, the impact in the Carolinas, particularly North Carolina, is of historic proportions.
Now, in the US, several
here with the latest is emergency in New York, a deluge of 2 months worth of rain falling on the city in 24 hours, causing severe flooding in some areas. Samara Theodore is here with the latest as things dry out a bit. Samara, good morning.
Good morning. So yesterday's powerful and moisture-laden storm capped off New York City's second wettest September on record, as torrential rainfall left those in transit in dangerous and simply impossible situations. This morning, New Yorkers drying out after a dangerous deluge left many areas underwater from record-breaking rain. Over the last 24 hours, unrelenting rain turning roads into rivers, cars stranded as people flee for dry ground, and millions of New Yorkers urged to shelter in place. In New Jersey, a state of emergency, floodwater swamping roads, making travel dangerous and nearly impossible. In Fairfield, watch as a firefighter hoists a driver over his shoulders, rescuing him from the stranded car in the middle of a flooded street, one of at least 18 rescues throughout the region. In New York, states of emergency in New York City and the Hudson Valley, one of the Big Apple's wettest days on record, with more than half a foot of rain falling. The NYPD sharing video of this sea lion that escaped from its enclosure due to the flooding, but returned without leaving the zoo. The torrential downpour sending water cascading down stairs at subway stations. The system coming to a complete halt as rain poured through openings and cracks. This video showing water shooting out of the wall at the 7th Avenue subway station in Manhattan.
Get off right here.
Riders on this city bus in a panic as water surges inside. Drivers abandoning their cars on the FDR highway on Manhattan's east side. At the city's LaGuardia Airport, one terminal shut down as waters rise. More than 1,000 flights canceled or delayed. Hard-hit Brooklyn receiving nearly a month's worth of rain in just a few hours. Vehicles plowing through flooded roads and floating trash. A whirlpool forming over a storm drain. Brooklyn's 4th Avenue looking like a lake. SUVs creating waves as drivers test their luck despite the dangerous conditions.
And you know what's wild about all this? As we see the ramifications of climate change persist, events like this will be more frequent. So let's see what we ended with here. So at JFK Airport, they saw 8.6 inches of rain. That was their wettest day on record since they began keeping that in 1948.
So, what is a tornado in its peak seasons? The tornado is rapidly rotating around columns of air that extend from a thunderstorm to the ground. It's often visible as a funnel-shaped cloud, and they're capable of immersing destruction with winds reaching up to 300 miles an hour. Tornadoes can uproot trees, destroy buildings, and they lift heavy objects in the air. The season, while tornadoes can occur any time of the year, the likelihood and frequency influenced by the season and the weather patterns. So in spring is March to May, and then in summer is June to August for tornado season. Warm temperatures and moisture can still produce tornadoes, especially during severe thunderstorms. Now, fall is September through November, and there's a second tornado season often that occurs in the fall, particularly in the southeast of the United States. This is a combination of warm, moist air and advancing cold fronts that can lead to a tornado development. In the winter, in December to February, tornadoes are less common in the winter, but they still can occur, especially in the southeastern U.S., where warm air from the Gulf Coast of Mexico may interact with strong cold fronts. So the tornado-prone region is known as the Tornado Alley. And this region includes states such as Texas, Oklahoma, Kansas, and Nebraska. The southeast states, including parts of Alabama and Mississippi, is also highly prone. So global tornado hotspots are other countries like Canada, Argentina, Australia, and Bangladesh. They also experience tornadoes to less frequently than the U.S. And so this would be the one.
Some breaking news just into us. As our Dana Griffin started to tell you about earlier this hour, we now have video of 2 reported tornadoes that have touched down in Texas. You're looking at one of them there, that twister in the town of El Campo. You can see it moving through that community. Let's go to meteorologist Michelle Grossman. Michelle, what more do we know, and what's the threat level like right now?
Hi there, Valerie. Well, we've been watching these storms pretty much since this morning. We've seen hail and now these 2 reported tornadoes. The National Weather Service will go in tomorrow. We'll confirm, look at the path for these tornadoes. But yeah, we're looking, all the ingredients are there. We're watching lots of lightning at this hour on radar. And we do have tornado watches until 7 o'clock Central Time. We also have severe thunderstorm warnings. And we will see the threat for 10 million people under the threat for severe storms. That includes hail. That includes winds gusting over 70 miles per hour. It includes heavy downpours. We've seen videos all day long of heavy downpours that's causing some flash flooding in the area. Dallas had a ground stop earlier today. So the problems have been going on since this morning. Let's go ahead and take a look at what's going on in terms of radar right now. This is giving you the picture of what is happening. Lots of lightning with these storms. You can see that there's lots of green and yellow and red and orange. The yellow, red, and orange indicates where that heaviest rain is falling. These storms have a lot of moisture to work with. They had that daytime heating, got the power that these storms needed. And that's why we're starting to see some rotation with some of these storms. Also on this map here, you see that red square. That is a current tornado warning. That's in portions of eastern Texas. And these storms are moving fairly quickly as we go throughout this hour. And we're seeing some of those tornado warnings dropping out. But as it moves to the east, we could see additional tornado warnings. Now take a look at this video here. I mean, that's just alarming. And that's where you get that shear, that spin in the air, because you have all these ingredients coming together that we suspected. And the National Weather Service did a really nice job the past couple of days warning us with this severe weather threat, putting a severe risk in place, and in fact putting enhanced risk. I'll show you that in just a minute. Right here where you see this orange shading, that includes Livingston, Houston, Lufkin. That is the highest chance for seeing those strong storms, and that's what we're seeing right now. So the Severe Prediction Center did a really good job in pinpointing where we are expecting to see these storms as we go throughout the rest of the evening. That's not the only spot, though. You notice that yellow shading. That includes portions of Louisiana, Arkansas, into Oklahoma, also bigger portions of Texas where we could see some strong storms. And notice these bullet points here. We could see winds gusting over 70 miles per hour. That causes damage on its own. That could bring down power lines. It could cause power outages, damaging hail. We saw hail earlier with these storms without that daytime heating. So certainly that is the threat as we go throughout the afternoon. And Valerie, we're anticipating the chance of a few more tornadoes. So we'll keep you posted, of course, as we go throughout the next couple of hours. Once we get to those nighttime hours, we should see some of this activity die down. Back to you.
Thanks for watching. Stay updated about breaking.
Some breaking news just into us as our Dana.
What is going on? I'm dragging. I think this is the last line.
A community near Pittsburgh is cleaning up today after a rare tornado touched down on Saturday, leaving behind downed trees and damage to homes. Thankfully, though, this weekend has provided a desperately needed break for large swaths of the Great Plains, the Midwest, and the South from a relentless stretch of severe weather. April and May typically are the busiest and most dangerous months for tornado activity, but this season has been exceptionally active. So what's driving the uptick, and why do tornadoes seem to be moving into more populated areas? NBC meteorologist Angie Laxman has our Sunday focus.
From Oklahoma.
That's a tornado.
To Iowa.
Did you see it?
To Tennessee.
Violent tornado.
Scenes of devastation across the country this week. Americans have always been fascinated by the power of tornadoes. From the blockbuster hit Twister in 1996. Oh my God. To the upcoming Twister spinoff that looks like it could be the movie of the summer. But the tornadoes we've seen day after day have been all too real.
That's a tornado, large tornado, right here, in view.
6 weeks of punishing storms have left a trail of destruction, thousands of miles long.
Everywhere around me, it's a war zone. It's all gone.
People across the country wondering, are tornadoes more common, and are they getting stronger?
When you look at the number of days where 30 or more tornadoes occurred on a given day, which would be outbreak days, those have increased.
Stephen Strader is an associate professor at Villanova and studies climate and natural disasters. And those tornado outbreaks he's talking about are responsible for 80% of all Twister deaths. One of the reasons? More tornadoes are touching down further east, outside the Great Plains, hitting towns and cities not used to seeing them this often.
There's many more people in those rural areas in the southeast where vulnerability is heightened. A lot more nocturnal tornadoes, worse tree cover, more tree cover. All of these influence the vulnerability and exposure.
Is climate change to blame? The answer, it's complicated. Scientists are hesitant to make a direct link between climate change and tornado activity. For one, tornadoes are too small and brief to accurately model. But one thing is clear. A warming climate provides the fuel for supercell storms, the massive systems that can spin off these twisters.
In the future, we expect to see more of those events. That fuel that feeds the thunderstorms is fueled by heat and moisture at the surface, and those are expected to increase as we go through the next 30, 40 years.
Experts say that as storm patterns continue to shift, humans need to adjust as well.
As cities grow and expand, there's more targets to hit when a tornado occurs. Think of the Wizard of Oz with the tornado dancing behind Dorothy as she's running to the shelter. It's not going through a field anymore. It's going through a brand new subdivision. So we have to be aware that how we build is just as important as how strong the tornado is.
And Angie joins me now live. Angie, good morning. It really has been a relentless 6 weeks or so for millions of people across the country. So how unusual is the tornado activity we're seeing right now?
Yeah, good morning, Willie. It's been quite an unusual start to the year. Since then, there have been more than 6,000 reports of large hail, damaging winds, and tornadoes, including more than 260 twisters across 19 states in just the last 2 weeks. In fact, this past April entered the record books as the second most active April in terms of tornadoes, behind only 2011. And there have already been 2 violent EF4 tornadoes in Oklahoma, the strongest to strike the state in 8 years. And this severe season is far from over, with another round of strong storms possible from Texas to Mississippi tomorrow. Willie.
Fascinating look at this phenomenon. Angie Lastman, thanks so much. Great to see you on a Sunday morning. We appreciate it.
Hey.
And finally,
boy, that's crazy. This is like literally right on the side of the house. So it's got debris. Looks like it probably picked up in the fields that are right to the right of us. Let's step out here and see. That's bananas, man. This is literally right outside the house. You see all that?
seeing that?
Dude, what is going on?
Let me see if I can. There it goes. It's about to touch down right here. There it goes. That one touched down right here. There go another one right here.
Well, they want the power. Dude, this is bananas. Man, I hope this thing dies out before it picks up, causes even more damage.
So, moving forward, y'all, they said in November of 2025, this was all the information from there with the 11 storms and the hurricanes, 5 reaching major hurricanes. This was according to Wikipedia. This information was updated as of now. So there's more names to this. You can get this information from the National Hurricane Center. And so, again, there's more names to the storms that were there. And they have names for the storms even for next year. So some of them they have rolled over and they moved them, and because they have the names already listed, and they roll them over if they have more storms than what's estimated. So yeah, they have the names up there already. So there's more. So I'm gonna drop these links in the presentation when I get ready to upload it. And so these are the storms from the East Pacific. These are the hurricanes. Again, there's a couple of more on here as well. And these are going to be listed in there too. So you have the ones from the Atlantic, and then you have the ones from the Pacific. And then they'll tell you, it's important to note that the naming of the storms are coordinated effortlessly from the meteorological organization. They facilitate those names. And then these are more tropical storms. So I'm not going to go into all these storms because I think on a video y'all out for a minute. I do want to get into this is a hurricane. It actually hit Florida. Right, so the impacts, although they're floods, still considered a storm of a different type, but it's still a flood, even with these giant waves. Right. The flooding behind that storm, that typhoon, that cyclone, that hurricane, the damage is unbearable. I don't understand how sometimes they just stand there and watch until after it happened. Yeah, let's keep over this one too. So getting into the climate shift, there's natural causes for volcanic eruptions, and we also know that. But you know that they release aerosols, and we release aerosols like sulfur dioxide, which is SO, and they release it into the air side, the atmosphere, and it forms a reflective layer that blocks sunlight. So in 1815, there was an eruption in Mount Tambora that caused a year without a summer. This was in 1816. That solar activity decreased solar output during the period, like modern minimum in 1645 to 1715, and it contributed to a colder temperature, part like the Little Ice Age and the ocean circular changes. So disruptions in the ocean currents, such as a slowdown of the Atlantic Mediterranean overturning circular, that's the AMOC, can lead to cooling in specific regions like Europe or the orbital variations. So Earth's orbital changes, I can't say that word, the cycles over 10,000 years influence the ice ages and the glacial periods, right? So human influences causes geoengineering. So hypothetical or experimental methods, including like injecting aerosols into the atmosphere. This could mimic volcanic effects. That's the pollution at high levels participating in matter from industrial activities that can reflect the sunlight, leading into those regional coolings. That's from industries with the pollution that it adds. And so the historical cold climate shift, like Little Ice Age, is the period of cooling the northern hemisphere caused by reducing solar activity and increasing volcanic eruption effect, including harsher winters, shortening the growth of seasons and the famine in Europe. And that last glacial maximum that was over 20,000 years ago was that major ice age where global temperatures were much lower and the ice sheets covered large parts of North America and Europe. So the modern cold climate phenomenon is the Arctic polar vortex. And the weakening of the polar vortex can cause cold air to escape from the Arctic and plunge into mid-latitudes, leading to extreme winter weather in places like US and Europe. And the localized cooling and the mid-global warming in regions like North Atlantic may experience cooling due to disruptions in the ocean currents, despite the overall global temperatures are rising. So volcanic eruptions impact, even though the current warming trend, like large eruptions, they can create temperature cooling effects, AKA like is Greenland warming or melting, is Iceland warming or cooling or melting. So the environmental impacts and the ecosystem disruption, species adapt to warmer climates. They may struggle while cold tolerant species could expand in their range. That's like fish. They can get as big as the tank or they stay as small as the tank. Adapting to the climate, like people, the glacier ice sheet behavior. A prolonged cooling period could slow glacier ice melting or lead to expansion in certain regions. The socioeconomic impacts on agricultural productivity is shortening growing seasons, and harsher winters could lead to food insecurity, energy demands, increasing the heating needs and strained energy infrastructure, and increasing costs. The infrastructure challenges, extreme cold can damage roads and water systems and buildings, especially in areas that are not used to these type of weather changes, these climate changes. And what this means for climate trends is the current climate change shift does not negotiate or negate global warming. Instead, it reflects the complexity of the climate system, where warming can exacerbate extreme weather, including colder conditions in specific areas where these key points were to be considered, aka North Dakota are having meetings about constant or the continuation of cloud seeding. The short-term, long-term, contemporary cooling events occur with the broadening warming trend caused by greenhouse gas emissions. The regional effects, some areas, particularly in mid-latitudes, were experiencing intensified cold snaps. Even the global average temperature rises. The feedback loops are Arctic warming and ice loss contributed to feedback mechanisms that destabilize weather patterns, leading to more frequent cold climbing shifts, global warming shifts. So where are you at? Here we go.
Environment Canada has issued an extreme cold alert for most of southern Ontario, including Halton, Niagara, and Hamilton, and that's prompted the opening of warming centers across our region. Sean Cowan spoke with paramedics today, and they say even a short amount of time outside can be dangerous.
It's really cold out.
It's cold like chili.
It's firstly super cold, and
and it's windy.
Bundle up and limit your time outside is the advice from experts.
Lots of layer. I also have like a balaclava. I wear mittens, I wear 2 pairs of pants, I wear a jacket and a sweater, sometimes a hat.
The city of Hamilton has issued a cold weather alert. This happens when current or anticipated weather conditions are at or below minus 15 degrees Celsius or minus 20 with the wind chill. While it is chilly out, it can also be dangerous, according to Hamilton paramedics.
So if we look back to the beginning of January, we've responded to 6 calls for frostbite or various degrees of hypothermia.
And Hamilton paramedics say it's important to prepare before you go outside and bundle up. They say any exposed skin can be at risk.
It can be any skin that's exposed, really. So, you know, that thinner tissue around your nose, your ears, your fingers, toes, things like that is definitely higher at risk, but you can get frostbite anywhere.
The city of Hamilton has expanded hours at 3 drop-in centers: Willows Place on Wentworth Street North, Carol Ann's Place on McNabb, and Mission Services Nightlink, also on Wentworth.
Generally, there's pretty good usage of those locations. There's significant usage of those locations, and they're well received by our clients that are interested in accessing that service.
Another way to keep warm is by giving back, and that's exactly what's happening here at Hess Street School in downtown Hamilton. Jennifer, tell me what's going on here this evening.
So the school council at Allen Greenleaf, we got together and we thought we'd put together a free market for the families here at Hess Street School. Everything you see was donated. We raised toiletries in our classroom at Allen Greenleaf. There's kids' clothes, backpacks, books, everything that you really need to get you through the winter, nice warm clothes, and we gave it away to everybody here.
So it's really about one school community coming together, donating and giving back to another, right?
100%, and it's all sweat equity. So it's just putting in the time and gathering those donations and being able to reach out and repurpose them.
And I see a lot of clothing items, a lot of...
Environment Canada has issued an extreme cold alert for most.
Yay! So, in the end, the concept of nature's balance refers to a delicate equilibrium with the ecosystem, and it allows life to thrive. And the balance is maintained through interdependent relationships among the organisms, the physical environment, and the natural process. However, human activities and natural events can disrupt this balance to both positive and negative consequences while maintaining nature's balance, and numerous benefits. Disruptions can also lead to cascading consequences that can affect the ecosystem and the human society. Striking a balance requires integrating conservation efforts with a sustainable development, fostering harmony between human needs and the nature's work and the natural's work. By respecting these intricacies in the ecological system, we can ensure the stable and thriving planet for future generations. With that being said, it's about taking accountability into what is really going on and start really looking into what is being said. This is why I went into this climate change. It was a couple of days ago when I found out that North Dakota was part of cloud seeding. But then I found out a few days, a week ago, I think, that they were starting to advocate against it. And so, yeah, because it's the negative that they, when we first started last year about CERN, and it was time to revisit it. So a lot of stuff that they don't want to cover, they don't speak on. But when you speak about almost a quarter of a century and the things that we're starting to see, and they're not saying it's not from it, but you're not saying it is from it. And when we calculate these numbers, it's something we need to start looking at. I can't play that. That was my last
No,
video.
you can't play that.
Oh, that was my last video.
Try it again.
Let me see. Hold on. Let me see. I hope I can. No. Oh, you sucker. That's all right. So I just like to thank all of the people that I use their research to make this video possible. Again, because climate change is serious, global warming is serious, and I do appreciate more than anything the end to this war. And I hope it don't start a new one. Right. So shout out to the USGS. That's another website. So a lot of these websites I'm really gonna drop down. I don't even know if they're gonna still be up, but we're gonna leave them up for the climate change. That's the USGS, the NOAA, the EPA, NASA, and NOAA. And I got some other ones in here for geological and whatnot. I watched a lot of earthquakes and whatnot and what have you during this segment, trying to keep up with the information, y'all, just to make this presentation possible and bring back everything I needed just to keep it current, because global change is real. And some of this stuff I had to remove because I don't want to gross you out at the same time. But yeah.
What is climate?
Climate is just the weather. It's between the two shifts. But global warming is part of that change. The climate is the change of it. It's let me get it right because we have to have it within our ozone. You remember how we was talking about peeling the ozone level? So if every pole has a shift, we got 2 poles, but at the same time we don't. It's 4. Does that make sense?
What are the other two? I know north and south.
Right, but you also have you have a north and a south, but then you have a east and a west because your winds blow. Do that, okay? So with the shifts, but then you have winds that blow. They don't blow north and south. They don't blow up and down. They blow this way. And then they how do you say that? One is hot and one is cold, but then they blow separately. And then you got temperatures and then you got shifts. So this is what I don't understand either, because heat comes from the ground up and water is cold.
Right.
Right. So climate is somewhere in between the two because climate shifts. So it's in the air. There you go. Find it. What did it say? Because it's interchangeable, because I know that if one comes from one place and one comes from another and they intertwine, you have a problem. Do that make sense?
Say that one more time.
If one comes from another and one comes from the other and they intertwine, you have a problem.
You're talking about hot and cold air?
Right. Like if in the ocean, if you have one storm coming from one place and one coming from another, you have a problem because one has a whole different air than the other one. And so you have a problem. Right, because one has a whole different, maybe warm air.
What's the weather like where you're at right now?
It's snowing. We finna have snow, cold snow
okay.
for a couple of days. Yeah.
Let me see. Are we getting snow? Yeah, it says we might get snow tomorrow.
Right. Because we riding the same wave, right? I'm from Canada. My stuff coming from Canada.
Gemini, what's the weather like where you're at? You're on mute.
Yeah, Ron. What's that? Fish are adaptable. They size up with their tank, and they say people have too over the years with climate, right? But
yeah, when you was doing yours, I was just thinking of how we talked about true north versus magnetic north, and I just learned that magnetic north changes. So throughout history, because of the Earth's material, whether it's like nickel, or I think it may have said something with nickel or something like that.
Wood nickel from the real nickel?
Whatever that mineral is. But basically, it's causing magnetic north to constantly be moving. And they said in like it's either 300 or 3,000 years, it's going to shift basically. So our magnetic north might really be like south or something like that. Like it's going to swap or something like that. I got a video if you don't mind. I could.
Yeah, go ahead.
Let me see. All right, there it is. It says what the upcoming magnetic flip will do to Earth. And this is NASA's scientific visualization studio. Oh, Gemini's still doing something.
Yeah, I don't know. What does it say, Gemini?
Gemini, you're muted.
Oh, okay.
What did it say?
It said that the terms global warming and climate change are sometimes used interchangeably, but global warming is only one aspect. Global warming refers to the long-term warming of a planet, and climate change encompasses the global warming, but refers to a broader range of changes that are happening on our planet.
Right.
So it's the framework.
Global warming is a type of climate change.
Yeah.
Yes.
And that only has to do with on our planet. What about like in like the atmosphere or the core? Does that count as climate change or?
I don't know. I don't know because when they're saying global warming just refers to the long-term warming of the planet. Yet, but climate change is the framework. It encompasses global warming and the like. So all the other things fall under climate change. Right. Global warming falls under climate change. What the glaciers, the shifts, all of that falls under climate change. Fossil fuels, all of that falls under climate change.
Right. We were talking about climate change.
Right.
Right.
All right, so I'll share this. It seemed like a pretty good video.
Earth's shield is weakening. In the past 3,000 years, our planet's magnetic field has lost about 30% of its strength, and it's still dropping. But here's what most people don't know. This might be just the beginning of something much bigger. Stay with me because I'm about to show you how this invisible force protects us every single day and what might happen when it starts to fail. So, Earth's magnetic field is our planet's first line of defense, an invisible shield stretching far into space. Without it, Earth Earth would look a lot more like Mars, a barren world stripped of its atmosphere by the solar wind. But what exactly is this shield, and how does it work? Earth is just like a giant bar magnet, but instead of a solid piece of metal, the source is actually a massive ocean of liquid iron swirling deep beneath our feet. This molten sea, about 1,800 miles below the surface, creates electrical currents hundreds of
1,800 miles beneath the surface. I never even thought to ask, well, how, like, what is the, what's the word? Depth of the
depth,
Earth?
yeah. How deep it goes, yeah.
Right.
How
Yeah,
deep is the core?
Right. Or radius, or whatever they want to call it, the distance from the core to the outer perimeter.
Yeah, yeah.
But 1,800 miles. Let me see.
Yeah.
Or magnet. But instead of a solid piece of metal, the source is actually a massive ocean of liquid iron swirling deep beneath our feet. This molten sea, about 1,800 miles below the surface, creates electrical currents hundreds of miles wide, flowing at thousands of miles per hour as Earth rotates. Scientists call this the geodynamo, nature's own power plant. The spinning metal creates a magnetic bubble around Earth called the magnetosphere. It's not a perfect sphere, though. It's more like a windsock in space. The solar wind, a stream of charged particles from the sun, compresses it on the day side and stretches it into a long tail on the night side. But here's the really cool part. This magnetic field creates two giant donut-shaped zones called the Van Allen belts, which trap harmful radiation from space. Think of them as Earth's very own particle accelerator, catching cosmic rays and solar particles before they can reach us. But this shield isn't as stable as we once thought. In fact, right now, something strange is happening to our magnetic defenses, and it's happening faster than anyone expected. Remember when I said our magnetic shield is weakening? Well, scientists have discovered a massive weak spot over the South Atlantic Ocean, stretching from South America to Africa. They call it the South Atlantic Anomaly, and it's like a dent in our magnetic armor where the field is significantly weaker than normal. This weak spot isn't just an interesting scientific curiosity, it's already causing problems. Satellites passing through this region regularly experience electronic glitches and failures. It's like they're passing through a cosmic weak spot where our shield can't protect them as well. But that's not all. Earth's magnetic poles are on the move. The magnetic North Pole is racing toward Siberia at an astounding 34 miles per year. That's about 3 times faster than it was moving in the 1990s. Imagine if your compass started becoming less reliable every year. Scientists have found evidence of this pattern before. By studying ancient rocks, they've discovered that Earth's magnetic field has flipped completely, with north becoming south and south becoming north, hundreds of times in our planet's history.
Wow.
The last major reversal happened about 780,000 years ago. But how does a magnetic flip actually work? Remember that ocean of liquid iron? Changes in how it flows can weaken some parts of the field and strengthen others. During a reversal, the field doesn't just switch off and on like a light switch. It's more like a dimmer that gradually fades down and then builds back up in the opposite direction. The process can take anywhere from a few hundred to a few thousand years to complete. During this time, we wouldn't be left completely defenseless. The field becomes more complex with multiple magnetic poles popping up in unexpected places. Think of it like a choir transitioning between songs. There's a period where both melodies overlap. What's crucial to understand is that we're not necessarily headed for an imminent flip.
Can I ask a question?
Go ahead.
Excuse me. Is the Earth alive?
Yeah. Absolutely.
What do you think?
If it was
Well,
dead, it wouldn't be growing anything.
I already knew about the core and whatnot. but I'm also because at one point hearing about the magnetic field, I also was under the impression that they could shut it off.
Who is the they? They can shut it off.
Exactly. So this is what's throwing me off. So I don't right. So this is also ever so shocking because I knew about the lava between the in the hemisphere. I knew about the rotation. I knew all of that. So knowing about this little dent, what have you, so that would only kind of match up with that whole that they're working on. So yeah, I can see that or what have you. But yeah, the magnetic field and now you're thinking like right, because I remember one time somebody put out this thing like at such and such o'clock they're gonna be turning off the magnetic field and everybody car ain't gonna work and all this other carrying on and this, that, and another, and they're gonna be shutting it down and all. Right.
I think that's a grid, not a field. They can't shut off the Earth's magnetic field because it grows naturally within the core of the Earth. But
right.
The grid, a grid is something they can probably shut on and off.
Well, it could have been a grid, but yeah, I'm just tripping on, just listening to this. Yeah. So, right. Because like I said, I knew about the equator and all this other stuff, but just hearing this, it's like tripping because that just put to the wild sound because we knew about the hemisphere and the to relate to the sound or the wild sound, but just to say this because couldn't nobody get to the hemisphere. We ain't tripping on that. I'm just tripping on that magnetic field. Yeah.
All right, here we go.
To places. Think of it like a choir transitioning between songs. There's a period where both melodies overlap. What's crucial to understand is that we're not necessarily headed for an imminent flip. Scientists have identified shorter events called excursions, where the field weakens significantly but then recovers without fully reversing. These happen about 10 times more frequently than full reversals, and we might be entering one of these periods now. But what does all this mean for life on Earth? First, the good news. We're not heading for a doomsday scenario. Remember, life on Earth has survived hundreds of these reversals before. In fact, there's no evidence that past reversals caused any mass extinctions. The most immediate effects are already visible in our technology. Satellites passing through the South Atlantic anomaly need extra shielding, and some even shut down their sensitive electronics when passing through this region. As the field continues, species that use magnetic fields for navigation, like sea turtles, whales, and some birds, would need to adapt. But given that these changes happen over many generations, they would likely have time to evolve new navigation strategies.
Hold on, it said...
That makes sense.
However, some animals might face challenges. Species that use magnetic fields for navigation, like sea turtles, whales, and some birds, would need to adapt. But given that these changes happen over many generations, they would likely have time to evolve new navigation strategies. Scientists estimate that at the current state of decay, it might take several centuries or even a millennium before we reach a critical point. This gives us time to prepare our technology and infrastructure. Space agencies are already developing better radiation shielding for satellites and spacecraft. Power grid operators are installing equipment to protect against geomagnetic storms, which could become more common as the field weakens. We're living in a unique time where we can actually study this process as it happens. With satellites like the European Space Agency's Swarm mission constantly monitoring our magnetic field, we're learning more about these changes than ever before. So while Earth's magnetic field is indeed changing, it's not time to panic. This is a slow, natural process that our planet has gone through many times before. What makes this time different is that we're here to witness and understand it. If you found this look into Earth's magnetic future interesting, Hit subscribe for more videos about our changing planet.
Hey, that satellite was ginormous. What the heck? Man, that thing is huge. What the what? Looking like a giant spaceship.
To study this process as it
that thing
happens,
was huge.
with satellites like the European Space Agency Swarm mission constantly.
Okay.
Wow.
Swarm mission.
Swarm mission. That thing is ginormous. I mean, woof.
Yeah, it
we have to
says
take a closer look at that.
Dedicated to unraveling one of the most mysterious aspects of our planet, the magnetic field. Although invisible, the magnetic field and electric currents in and around Earth generate complex forces that have immeasurable impact on everyday life.
Come on.
Mm-hmm.
Come on.
Yeah, because all we'll do pretty much is adapt. You know, the Earth is perfect, and everything about it is perfect. It's adapting the same way everything else is adapting with time. You know, sometimes changes are necessary. The one thing that I want to bring out is when you brought out that the compass, the true north, and how the compasses were off. So, you know, by this calculation, we would also have to redo some things here on Earth that we use to navigate as well. It'll be more than just the animals having to evolve and evolve their navigation, their internal navigation system. Is things like compasses, things that we use to travel, would also have to change. Look at that. That is so massive.
Yeah, I think they said it was deployed in 2013 or something like that, or built in 2013. Where is it?
Wow.
Launched November 22nd, 2013 into a near polar orbit. Okay. It's dedicated to creating a highly detailed survey of Earth's geomagnetic field and its temporal evolution, as well as the electric field in the atmosphere, by using a satellite constellation that carries sophisticated magnometers and other instruments. It was designed to operate for 4 years following a 3-month commissioning phase. In November 2017, the mission was granted a 4-year extension to 2021. It was then extended further and will operate until 2025.
What type of data is it collecting exactly? It's just collecting data about the magnetic field, or is it collecting other data?
Okay. Primary objective: study of core dynamics, geodynamo processes, and core mantle interaction. Mapping of lithospheric magnetization and its geological interpretation. Determination of the 3D electrical conductivity of the mantle. Investigation of electric currents flowing in the magnetosphere and ionosphere. What's the mantle in the core? Well, we know the core. What's the mantle?
That would probably be the top or the ledge, like a mantle. Like, you know.
Let me look it up.
See. Yeah. When you think of a mantle.
It's the mantle. The mantle is the mostly solid bulk of Earth's interior. It lies between Earth's dense superheated core and its thin outer layer. Okay. Let's see if I get an image. Okay. Maybe this one right here.
Yeah, there we go.
So it said it's studying the study of core dynamics and core mantle interaction. Okay.
That's wild.
Yeah, I really wonder what's going, like, if we looked at each landmass and just went deeper and deeper beneath it. I wonder what's beneath the land masses, like in this mantle region, but like closer to the
surface.
The surface, yeah. I wonder what.
That wouldn't that be like geological? That would be. I'm pretty sure they got a lot of geological findings.
Well, we do know, like, there's probably like oil, right? We're gonna
Mhm.
find out like oil, gold, all those
other minerals.
Mm.
So is that what that's what you and Sakina are when you guys do your study on Pangea, though, right? So you figure out what is underneath the surface that causes the seismic, shifts.
Yeah, we're gonna have to. Yeah.
Okay.
Left, right, left. Go ahead.
Wow.
No, I'm just saying, looking at like that representation of all the magnetic activity or energy going on. I mean, that's complex.
It really is. Very interesting. Very, very interesting. You know,
And
we know the Earth, right, had a built-in shield because, we would have been, flooded with all types of radiation by now. So we know that the Earth has a shield, but to look at it like you presented it in real time is very interesting. Like, wow. Because there's lots of things that cannot enter into our atmosphere due to the fact that we have a natural shield around the Earth. So that only makes sense right there.
Oh, here we go. See, I don't know kilometers. Do you guys know how kilometers convert to miles?
No.
No.
It's been so long since I've had to do that kind of math. Not her. When it comes to that. So when you guys go deeper, that's something you should probably have out a kilometer. Hold on, let me finish. Sakina, you interrupted me. I'm about to sit here and say, hold on. Y'all should probably have a kilometer conversion calculator out, because that would be interesting to know the conversion on how kilometers, transfer to miles, because they said 1,800 miles, which would be how many kilometers? I don't know. 1,800 miles to get to the core.
Right, and that's why I was going, because I thought it was converted from miles to kilometers. That's what I was saying. I'm not sure, but that's what I thought. They were doing miles versus kilometers. They say such and such miles equals X amount of kilometers. What they would say was so many kilometers, and they say that equals this amount of miles. But at one point they were saying miles, and then they would say it was X amount of kilometers.
Okay, so the core of the Earth is hot, right?
Right.
So is the core of the Earth like the sun?
No, it's actually lava.
I was gonna say, yeah, like a volcano, because when it erupts, it's erupting from the core up.
Okay, I didn't know that. Okay, because I'm just seeing a similarity. Like, is that anything like the sun? Because the sun is constantly erupting. If you look at some of the demonstrations, like it's bursting everywhere all the time.
Yeah. Right. Yeah.
Well,
but
they
not
call
in
it
the form
plasma. Go ahead.
Yeah, but not in the form of lava. So I think the core, because that picture you just showed actually said liquid. One of the pictures that she showed, one of the layers was liquid.
Okay. Yeah, I see that.
Right. So the sun produces plasma, and the other things produce lava. Now, what's the difference between the two? So they call it. Remember, Gemini, when they was taking plasma from the sun to do their experiments, and the other ones produce lava. And so That's the gas emergence or whatever that they put in from the smoke that comes from the green gases that they put in from the earth, volcanoes that's going in the earth that's causing them greenhouse effects and whatever that's giving global warming. But we talking about climate change, but still this is that. You see what I'm saying? And they taking plasma from the sun to try to do something else.
Yeah, they're trying to find out more about it. But Jay, you know what? You brought up a point there, because maybe, you know, this shift in this magnetic field, when they're saying these dents, and they're saying there's no real effect, well, there's mild effects. Maybe the global warming or the climate change is one of them. And when Sakina was showing all of the videos, the one thing they all had in common was, and that was just last year, she was showing videos from 2024. The one thing that they all had in common was each weather, what's the weather's title? His name, what's his official title? The weather person.
Meteorologist.
The who?
Meteorologist.
Yeah, the meteorologist. Yes. The one thing that they all said over and over was the events were occurring. Certain events were reoccurring over and over and over, and more times than what they have tracked in years.
Right.
So when we were talking about tornadoes, he said this is happening 10 times more than it has happened in years. When it was the floods, they said the floods, you know, these things were happening, you know, twice as much as years before. When it was the hurricanes, they said we have more hurricanes and more names. These events are occurring more times than what we have tracked in the past. So
devastating and more devastating.
And so maybe the shift is causing mild instances for the weather, you know, being picked up like this. Maybe it's the weather is picking up on it as opposed to people and animals. That's what I was saying when he said that it's going to affect more than just the internal navigation of the animals. It's going to affect some things on Earth, you know, such as our compasses and things like that we use for navigation, because it's literally saying it's starting to flip. So your north and your south are beginning to turn. What did it say? It's about 34 degrees going towards Siberia. So it's changing. You know, so maybe some of this climate change that we're facing could be due to some of that magnetic field just changing, fluctuating, rather.
This yellow line is like showing the migration of the magnetic north. So like 1350, it was over here, 1400. So it's been traveling.
Right.
And then this here shows the axis that the Earth is on. So that would be like the true north. And then this is showing the magnetic north. So there's like a separation.
Yeah, that's what it was saying, about 34 degrees. So that looks about right. That's about right. That's what it said. Wow.
And I had a video on the polar vortex. It didn't come up, but I also put it in the algorithm, so it's already out there. So this kind of would have covered that, but it didn't pop up. But yes, this is good. So I'm glad you did that, because the polar vortex is also part of that winter piece that I wanted to play, but I didn't want to word it up too much. But I appreciate this very much.
Because it was saying it said 34 degrees. Did it say 34 degrees every 10 years or 34 degrees just period? I think it said something it's been going about 34 degrees, over towards Siberia, you know, every 10 years on average. Yeah, it's been moving.
Right. And then
direction.
And just to throw in there, I did look up climate, and climate was is just the average weather condition for specific areas over a long period of time. And so that's just what it is. And it links to the result of averaging weather patterns like temperature, precipitation, humidity, and wind over many years. The explanation is weather, the short-term state or atmosphere over a specific location. So again, it's just being wrapped up. So yeah.
Well, and I mean, you can see the effects of
Yeah.
whatever is going on crystal clear
Exactly.
because it here in the Midwest, and this is just since 2013, our snow has decreased. When I first got here, yeah, it was snow. We got about 10, 12 inches of snow on average. And now this is 2025. The 10 inches we got was more than the 10 inches that we got in the last 2 to 3 years here.
Yep.
Right? We have not had our snow has totally nosedive, took a nosedive. It has declined. And then you're talking about the one and only time that the South got snow. And they got more snow than we did. And we are a place where it snows, where it gets cold, and where those types of things. So when we're looking at what's happening, clearly climate change is happening.
Yeah, it's changing.
You can't deny that.
Yeah, just quite practically, the climate is changing.
Yeah.
Like the last big snowstorm I remember, we probably got like a few in between, but I was in college in Connecticut in like 2013 or 14, and we had like mountains of snow on campus, like just straight up mountains. I don't know if y'all got some of that, but that was like 10 years ago, 11 years ago. But since then, it's been very mild.
Very.
Like Christmas don't really snow. I remember when I was a kid, it used to snow.
That's right.
Yeah.
That's right. None. And for and for that burst of snow to come in the South like it did, that was like wow. So that right there just really showing you that times have changed, and where people have thought that a lot of places were safe, like Floridians never probably thought that would happen. All those hurricanes back to back to back to back to back to back like that. That was probably like wow. It was so it has been changing, right? We don't even really. I mean, it's good that they study it because we really need to get ahead of these things, like they said, so we can sit here and learn how to properly prepare. So if we get ahead of it and understand what's happening, in real time with our technology, with the use of technology, we can be just fine. But can you imagine some of these changes happening and we didn't have this technology? That'd be like, wow.
Yes, I like that word, real time. Real time. That's something we gotta work on, real time. California, this is my last thing I'm gonna speak on. That devastation was a fire, and then after the fire, then it rained, and then they got hit with the rain, with the flood and mudslides, and then after that it snowed like all get out. I mean,
it's going to though, but for the rain after a fire, that's going to happen because the clouds are agitated, right? So with all the fire, so the rain after a big fire like that, is the way that goes. One thing that shocked me was that the cloud seeding, when you're talking about using the silver oxide like that to agitate clouds so that it will snow, so that it will rain, things like that. And it's almost to the point where the way the weather's been changing, we don't really need much cloud seeding. We don't. It's just a lot happening just all on its own lately. So in the next 10 years or so, it's going to be real interesting to see, where the declines and where the shifts are, here in the country that we live in. All that rain that happened in Spain when they got mudded out, I don't think they ever saw that coming. It killed way more people. What did it kill? Like 200 and something people? I mean, that had to catch them by surprise to kill that many people.
It was
by mud, death by mud. Oh my gosh, that was, to me, that was devastating. It was like, wait, what?
New York was a shame. It was, it was so many people. 2004. They didn't even give a accurate number of floods, but
it was 24. You kept saying 2004, but
it's 24. More. Well, it was more than that, but I didn't get an accurate number because remember I had the spots open. I just got the number of tornadoes, I mean, not even tornadoes, of earthquakes, right? And that one blew me back. So I was still trying to wait on the number of tornadoes and just the rest of it, but to separate.
I mean, they have lots of tremors and lots of little earthquakes all the time, but just the big ones that we feel.
Right. So that's why instead of me reading them off like that, I just did it in a video. I just kind of went through it.
Yeah.
Because 300 and some odd thousand, it was over, it was almost close to 500,000. It was over 300,000, almost 400,000 within the year. And that also included the ones that happened up to January. So,
because I would tell you, I will share this with you. Growing up in LA as a kid, there are way less earthquakes than what I remember as a kid. When growing up in LA, we had earthquakes all the time. Right, that great big one in Northridge. I was working in the mall when that one hit. Right, and so they've had way less for whatever reasons than what we've ever had. I mean, it used to be. I mean, boy, in 1 year, oh man, I remember at least 4 or 5. That kind of thing. So even their climate has changed. So. It's like, what is going on? Now you hear about an earthquake. I like the one that we just had in Maine. So now we're hearing about earthquakes in other places where before you never really heard of earthquakes in some of these other spots.
Right.
What causes wind gusts, like strong winds?
Like our Santa Anas? I don't know. I was telling Sakina about that, and I think she did some research on those Santa Anas. Santa Anas is something we've always just had too. In California, we've always had Santa Anas. I was telling Sakina as a kid, we used to have to hang on to the poles, and whatever it blew, it was just done. Don't even call yourself going to go chase it, because sometimes the winds get so bad out there that it would flip over a 18-wheeler truck on the highway. So little cars and stuff like that, you learn to drive with the cars, because that helps shield from all the hard wind during the times of the Santa Anas. But it's just when we have a wind season out there. So I don't know what causes the Santa Anas.
No, you answered it, because I learned a lot from Gemini. Y'all just don't know, but she answered it. It's a natural thing. It's just an event that happens that on a specific time of year. It's just that, right? That's the Santa Ana winds, and it's a natural.
It's not from the water. It's not from the water.
It's just a natural wind. It happens a natural time of year, and it's something they're used to, and that's why it has a name. It's a natural thing.
Phenomena.
Yeah. And that's what it is, and I guess she's so strong. She got her own damn name. She Santa Ana wins. She ain't playing.
We did. We used to have to go to school in that mess. And here's something people didn't know about California: the fog. We get a fog season too. In that fog, you can't even see your hand in front of your face. We used to have to go to school in that too, and we used to have to cross big streets. Can you imagine that? None of us died as kids. None of us ever got hit by a car during fog season. And that fog season is hefty.
Yeah.
You with hindsight, you look back on it and you're like, yeah, none of us ever got hit by a car now that damn thick ass fog. We couldn't even, we used to just be, I don't know. It's wherever you live at, you just adapt naturally and you don't even think about it.
Wow. Listen, California is I've seen some beautiful sights. Like they like listen, they like almost hidden, but they're not. And waterfalls
pretty places out there.
just
Yeah.
pop out of nowhere. Like New York got some of these same places out of all the stuff you see in New York, and people talk about New York, but popped out of somewhere in New York is like you will find this beautiful somewhere in the middle of nowhere, and it's a whole waterfall. And
yeah,
like, well, dang, out of all the stuff they talk about in New York, nobody never said nothing about this.
Right.
You see what I'm saying? So yeah, California like that. And I believe
there's a lot of beautiful places in California. Lots of beautiful places there are.
Yeah, I think
deep
that
in the mountains where you can't see.
That's what I'm talking about. Yeah. I think that wind come from around the mountains, and when they get through whipping and turning and whipping, when she get through coming around the mountains, here she come. And she
ain't that part.
And she is not playing. She mad.
And she ain't playing.
Yeah.
At all.
That's what I think. Jay, you be asking some good questions. What, you got a good question book?
No, he's so analytical. Jay is very, his critical thinking comes from an analytical side of him.
Listen here.
He applies critical thinking to a lot of things. Yeah.
He was ready for school. They said, "Oh,
he was ready for school."
Yes.
I was gonna ask y'all, since the core is hot, how do you think the Earth formed?
But
and is outer space cold? Is outer space cold?
but you need heat, right? So you need cold to produce water, and you need heat, right, to warm things up, to help things germinate, right? So because even when a seed is planted deep in the ground, it's warm, it's shielded from the cold, it's getting the water, right? The roots are looking for the water, part of it. So it makes perfectly good sense on how things grow naturally within the earth, trees, and how organisms could grow from and benefit from some of that too. Natural organisms in the earth. I mean, it makes perfectly good sense, to be quite honest. It's a great combination. I don't think if people never was to live on this earth would be alive and still growing and thriving. And I bet you 350,000 years ago, it looked absolutely amazing around some parts.
Right.
The problem with it is that as we, as the years, start to go on, you take the forest in the Congo. No one wants to live in that today. I don't want to, as beautiful as that is, it's also very dangerous. Lots of things that have survived all of these years because it's pretty much untouched over there, right? And they only have the tourists, and the tourists make sure you go through a safe part of that jungle in the Congo so that you don't get eaten by some unknown thing, right? And you have places like the Amazon, places where you even still have people over there that pretty much are untouched, and that have evolved over the years. But no one wants to live like that in 2025. It was beautiful. It's beautiful and it's nice, and it was probably at its peak back in 1875, right? 1825, 1720, 1625. But it's 2020. No one wants to live in the jungle. So as beautiful as it is, we still needed to have a certain amount of progress.
But
we want to live bug-free and animal-free.
You take that man out of the jungle and put him out here, he probably would not want to be out here. He probably would want to go back to the jungle.
He probably would want to go back to his bugs and his animals. Let him. But the great majority of people don't want to live like that. It's just it's not the fact that it's unnatural. It's just the fact that we are progressive forward human being organisms. And so we progress forward. We don't progress backwards. So someone who is taking a lot less time to progress probably wanted to live like that. That's why you still have.
then that's what I'm saying. If that's
well,
all
I'm
he's
saying,
doing,
but it's not very many people like that. Only the protected people of the Amazon live like that.
right, right. That's what I'm
Yeah.
saying.
And so, yeah, but it's very few of them, right? Versus, mankind. Mankind is going to always have a need to progress. And so we can't be living in the jungle like that. We just can't. It's just not what we're going to do. It's beautiful. Lots of pictures. You see lots of picturesque views. Your whole camera filled up with pictures. I was looking at that, even that African elephant that lives over there in the Congo. To see that African elephant, Congolese elephant, and they put it side by side. It's called the black elephant, lives in the Congo jungles, and they rarely get a chance to see those elephants because these elephants are in the wild. They live in the wild. They're born and bred in the wild, and it's very few of them because even the animals have evolved. So the elephants do not look like those elephants there in the Congo. They look like them, but not for real. When you look at the features and everything, you can see how even elephants have progressed naturally. They don't look like that no more. The ears, the nose is different, the paws, and the everything about that elephant is different as night as today, from the elephant that we know today. And so things have a natural progression, no matter what it is. It has a natural progression.
Well, damn.
Yeah, it looks ancient, right? Those elephants in that forest look ancient. They look like they belong in a museum, except they're alive.
That's you.
Yeah.
I remember one time I went to the Byron and Baleen Circus, and this every time they brought out an animal, I was going, "Oh no!" I must have went to the bathroom when I came back. I seen these kids riding this dog, and I was like, "Why them kids riding that dog like that?" They was like, "Shh, Mom, that's a horse," and I was like, "Oh." Because I thought it was a greyhound dog. You know how the greyhounds is built like with the little skinny frame in the middle? I thought it was a dog. I was like, why is they riding that dog like that? It was a horse. I was like, Byron and Bailey need their ass whooped. And then when they brought out the elephant, girls, some people was riding the elephant, but when they took the cloth off and then took the seat off, you could see the little holes and rubbed off pieces on the elephant. And I was like, oh, not the elephant. And then when they said, you want to bring out the lions, I started crying like, no, not the lions. And girl, listen, they was looking hungry and skinny and shit. And I was like, oh.
Yeah, this is why a lot of people are against, the circuses and zoos for that matter, because, zoos, although they're great for learning and looking at animals in real time, they're just not conducive for their, for that. It's not a natural environment for those animals. And so, I stopped going to zoos, a long time ago. I told you when I found the farmstead, because the farmstead, the animals are freer. So you may not have tigers and bears, at a farmstead, but it's a lot better, and your children will get a lot better experience from an environment where animals can, roam and naturally, live mostly in their environment. But a zoo is just, I think a zoo is horrific. I'm really not for a lot of zoos. I don't think they take the best care of animals at all. But me, I'm against fur. I'm against people who wear real fur. People who destroy, our naturalness in the world. I can't. I can't stand for those things.
That's why you don't eat meat.
No, as a matter of fact, I don't eat a lot of meat. Now, I will continue to tell you, I eat bacon. Stop playing with me. Bacon is meat. I eat bacon. I don't eat meat. I eat bacon. But no, you won't even find that in the house like you used to. Not when you see the extreme conditions. No, it's yeah. So time brings about a change, right? So that everyone can begin to see, the things that we should be taking care of versus the things that we neglect. And I'm always happy to see, young people when they go into the field of zoology or veterinarian, to take care of the animals.
Right.
I don't know if you saw that during the not too long ago, maybe I'm going to say 2 or 3 weeks ago. They had was it a flood or a snowstorm somewhere? And the mama dog, this was a German Shepherd. The mama German Shepherd took her baby. The baby was sick, was not moving. So she brought it to the veterinarian. She knew where the place was where human beings, took care of animals. So she picked up her baby and brought it all the way to the door of the veterinarian and barked. And the veterinarians came out there and they saw the baby German Shepherd, not, lifeless. And they helped them both out. Don't know who dog that was, but, things like that, it's very hopeful when even the animals know there's a safe space for them to go to. Thought that was very interesting. Very, very interesting. And when I saw that, I said, no wonder canines are, police and military dogs' best friend, because look at the capacity for learning and understanding and just flat out caring about its young.
Wow. Listen here, I love my pet. I love my daddy.
Yeah, very interesting times we live in. Jay, that was great. That was a great video.
Yes,
I must say, it did make you think about some deeper stuff. And so now I might be interested in you and Sakina's show about Pangea, so that we can find out some other interesting things about the Earth crust in the seismic shifts.
Yeah, y'all gotta try to get Truth over here. You be sending me stuff about Japan doing animal-human fusions and all types of weird stuff. Because he's really science. I'm not really science, but he's science.
Yeah.
Yes, we need to.
I mean, because you don't have to necessarily be 100% science in order to be interested in the things around you. Everyone should have some basic knowledge of everything going on around them. So science is included. We should know about the very things, that we thrive in on our day to day. I think that fits right in. So you have some people who just take more of an interest in it than others and pursue it, a little bit more in depth. But it doesn't mean that we all can't be or like Uncle Keck's word, scientific literate. It doesn't mean we can't be scientific literate, because we can.
Ain't nothing gonna be the failure but a try.
There you go.
You're right. The interest, all you gotta do is show it, and somebody else will help you if they know it.
Okay, so we're coming into the second hour.
Yes.
Sakina.
Well, I appreciate everybody for being here, so we can start looking into these things for not global change, but for climate change. We see it happening, right? And so we need to try to see what we can do to try to see what we can do to make some changes and look at these things, these changes going on, right? And look into our states and see what they're doing, and maybe we can help to make and add to solutions, see what they're doing, so we can add to it to improve these solutions, because some of it is governmental, but then we still have to do our share. So let's look into those things and revisit them, y'all. Each one teach one, reach one. I'll end with that, Gemini.
Okay, well, thank you so much. I appreciate being here with you, taking out my busy schedule to always learn something new, always learn something more, always broaden, what I do know. Appreciate, Jay, Roundtable Gang for always, supporting us the way that they do, all the mods. Salih Ben Yah, he's always hanging with us no matter where we at. I appreciate you for doing that. For sure. One of these days, you're going to have to hit the link and come and chit chat with us for sure.
So wait, are you guys still doing was it Saturday back to back, or it's going to be Wednesday, Saturday?
No, we're doing Saturday back to back. Brother Reggie is going to join me Saturday with the Black City Plan.
Mm-hmm. Okay.
So yes, we're going to talk about the Black City Plan, and he's going to be talking about that and his ideas on it and what stemmed him moving forward or talking about it, creating it, and all of that wonderfulness. And yeah, we're going to talk about that.
And so I think the date, Sakina's date, my dates are fixed pretty much because my co-host can only come on those days for now until we can figure out, get some pre-recording. But there's a lot of juiciness. I may decide to come on a few, through the week too, because there's always so much news right about now with 47 in office. And so there's a lot of interesting things that I want to discuss, but usually I try to save it for that one day so that they can chime in, so that we can talk about it, a little bit more. And so Sakina days are Sakina days. So that's why he was asking, Sakina, are you coming on Wednesdays too? Now you're going to come on Wednesday. And Jay, if she got you as the co-host, she probably can come on a little bit more too. So what are we talking? What you talking about?
Oh no, I mean, I'm here almost every day. I'm on YouTube, so.
Well, yeah. So it's right. Me and Jay gonna talk in a minute, and then because right, we got some we got work to do.
There you go.
Is a whole right. We gotta drag that.
Yeah, seriously. I think that would be good. And then streaming on both platforms. I think that's a win-win. The show today was fire. I mean, you two work really good together, co-hosting shows like this.
I appreciate that especially because my thing got dropped and he picked it up, not even knowing. See that magic? And then he expounded on it. I love the way Jay researched. I tell him that all the time. Right.
Yeah,
So
I do too. Jay is definitely is that a word? Geographic literate?
Come on, we're gonna have to make a word up for him.
That kind of thing right there. So yeah, I can see this in the future growing, because I think you guys work well together. And that makes all the difference.
Very much, very much. So with that, Jay, can you lead us out?
Oh, I mean, hopefully we do more in the future. Keep expanding, keep learning. I'm trying to remain neutral and moderate on most of my opinions, because sometimes I'll be looking back or listening back and I'll be cringing at some of the stuff I'll be saying. So I'm trying to remain more neutral and moderate and just be open-minded, not so strongly opinionated. And that's how I want to move going forward.
Growth.
Yeah,
but that's growth though. So that it's supposed to. I don't think if you reflected and saw back, some of the changes, you wouldn't be growing as a person. But growth is necessary and needed. It's how you build. It's how you broaden what you already know, the scope of what you know.
Or what you think you know. Because I thought I knew a lot of stuff, but I'm always learning something new.
Yeah.
growth. It's called growing up in your face. That's why you research the way you do.
Yeah.
Because not only are you knowing what you know, but you're building and growing what you know. So again, there ain't nothing beating a failure but a try. And because you went in with what you know, you're expounding. Just what she said. So again, you're growing up all in your face.
Mm-hmm.
And you're good at what you do. You're good at what you do. You actually make critical thinking look good, right?
Mm-hmm.
The analytical, you make that look good because, it's not just any kind of questions that you throw out there. You throw questions out there that cause the person to think. And as they're thinking, then you're still growing.
Right. And you asking yourself and you're looking it up yourself. You see what I'm saying? That's growth.
Yeah, you do a good job, Jay. You really do.
And science is hard.
Science is hard.
Well, for me it is.
It's hard for everybody, but science is math. Math is science. What are we saying?
Yeah, so I'm following y'all lead on the science wave. I'm tuned in.
Oh, we following you too. Ha! Come on in. Yay! And with that, we love you all.
Jay, don't leave. Jay, don't leave. We finished to end the stream. Don't leave though.
Okay.
She got style.